students, in this lecture we will discuss the another method to form or find the position of image of an object which is placed in front of lens. Okay, for this consider that you have a convex lens of focal length f. For that lens of focal length f, there should be two positions on the principal axis for the two distinct images which are clear on the screen. Let's say the two positions, one is position of object and another is position of screen. So because there is two positions, there is two images or two different images can be formed for the same lens at the screen at a distance which is we have assumed. Okay, so for this case or such cases, lens has two different positions to form the image of the same object on the same screen at a distance placed between them. Okay, let this is a principal axis and this is location 1 for lens and this is location 2 for lens. Okay, on any location the lens can be fixed. Okay, therefore let an object which is placed in front of lens, let's say at O. Okay, and this is the screen x test or either xy. Okay, this is that screen at where the image is formed by the lens at two different locations which are clear and distinct place on the screen. Let's initially okay, so this is how the same lens can form the image at the same distance placed in front of the lens, either case L1 or for L2, having the same focal length f and f, because it is the same lens which has the two positions to form the image of object which is placed either at location this or from this much location from the lenses. Then in the two position the lens can able to form the clear distinct images at A dash, B dash, and for the second situation A double dash, B double dash. Okay, now for it let us consider that the distance between the two lens be x. Okay, and the distance between object to the screen is d. Now because the same lens having same focal length have the two different locations, so their position can interchange itself. That is, this is u and from here this is also u. Clear? So two distances O dash or we say B to O is u and O dash to B dash is also u, or either we say that the image distance from the second position is equal to the object distance as the object in front of the first lens. Okay. Okay. So this is the first case. Now the image formed by the first lens at this location, this is equal to V. Okay. Now, according to the figure, if this distance is V and this is X and O to B is U and O dash to B is also U, so we can say that this distance from the second lens is also equal to V. This is our situations to form the image or find the position of image by using the Newton's formula. Now we understood about the cases. Okay. We know that the magnification. Okay, 1 minute. Condition start for first location of lens. First location of lens. Okay, that object U is at OB distance, which is negative, and image distance is V, which is OB dash. Okay. Second, magnification of lens is V upon minus U, and this we have OB dash upon OB. Clear? That is, we can also write it as height of image A dash B dash to height of object AB, that is I dash upon object. Okay, this is HI and this is HO. By using the magnification formula, this is our equation first. Now for second location of lens, which is at, therefore object distance which is O dash B is equal to minus V. Okay, and image distance O dash B dash is U. Okay, now from figure, this is, let's say, M1 for the location 1 and second for the location 2. Magnification of the second location is minus U, which is distance of image distance. Okay, distance of image, and minus V because it is distance of object. Okay, so this we get U upon V, which is equal to height of image I double dash to height of object. Okay, because the image is formed at the same location, we can use this is I is equal to O, and the initial case is also the same. Therefore, this is our equation second. Okay, now because in the previous lecture we will discuss that when the two lenses are in combination, then their magnification is the product of the magnification of the combination. Therefore, m1 into m2 is equal to I1 or I dash into I double dash upon O into O, that is I dash I double dash upon O square. This is the value of magnification produced by the lenses. Okay, now by using the ratio m1 upon m2, that we have m1 is v upon u negative, and m2 is u upon v. On solving this, we get v square upon u square. Okay, now we calculate the value of v and u. From figure we can calculate that v is equal to, how much is v? One minute. The distance of object to the screen is d. Therefore, from figure first we have d is equal to u plus x plus u, which is 2u plus x. Now calculate from here u, that is d minus x upon 2. This is the value of u, and v is equal to d minus u. It is clear? So this we get d minus x upon 2. On solving this, finally we get v is equal to 2d minus d plus x upon 2, which is v is equal to d plus x upon 2. This is the value of v by solving this figure. Okay, now according to lens formula, that is 1 upon f is equal to 1 upon v minus 1 upon u. We get 1 upon d plus x upon 2. Okay, this 1 upon v we get 2 upon d plus x. Clear? So this 2 multiply in the numerator and minus this, again we get the same 2 upon d minus x. Okay, now by taking square, one upon f is equal to 2 is common in the numerator, d minus x and minus d plus x upon d square minus x square. Now here this d cancel. 1 minute. And this. So the final result which we get from here is 2 into minus 2x upon d square minus x square. Okay, by taking reciprocal from here, f is equal to d square minus x square to the power in denominator 4x. This is the formula for 1 minute. Here we have negative also because this, so this negative cancel by this and we get the positive result. Okay, this is required formula. Thank you.